What's up, guys? This video is going to cover the Breakout project. We're going to follow the tutorial for the bricks, and then instead of following ball, paddle, collision in this tutorial, we're going to reuse them from the Pong game that we already made, which is going to save us a lot of time. So let's get going on this, which is filled with the constants they provide. It has numbers for the size and location of different things. Let's, instead of making a bunch, start by making one. I'm going to do a function, let's call it make brick, and it'll do a single brick, which then we can call that in a loop or wherever we want to repeat the job. So I'm going to give it a row and a column, which we can then use to figure out the X, Y, and color. So first we're going to go let brick equals new rectangle. I know that because we've done that a lot recently. We made the flag with rectangular stripes, and we made the Pong game with rectangular paddle. So this is not new. And in fact, we don't even have to determine the width and height. Those are already set for us at the top of the file. Now, of course, we can change it. I was thinking about making them bigger because it looks weird to have those tiny little bricks, but we'll have to make them adjust to each other. If we change the amount per row, we got to make sure that it adjusts the size to match. Now, let's just say add brick. I want to test the absolute minimum and see if we're on the right track. So if I run this, look, we get a brick in the corner, so we know we don't have any syntax error or anything like that. Let's get an X and a Y and then a position. So we'll go brick dot set position X, Y. Speaking of, that reminds me, I didn't even put the values in here for row and column. So JavaScript lets you just try stuff and gives you an error only if it really has to. But in this case, we should have provided a row and column. So let's say, okay, we're going to figure out the X, which is how many pixels over, and the Y, which is how many pixels down. It looks like this text is kind of small on the screen, so I'll bump it up. So what do we got to do here? Well, we're going to say that there's a thing called brick spacing, which is the breathing room between each of them and on the outside between it and the edge. And then there's a slightly bigger number at the top. Okay, so we're going to start with that for sure, plus how many do we move over for the brick. So if we're in like the fifth column, that means there's 4 bricks leading up to us, and we have to scoot over by their width. So brick width times column. I know it's weird that we call it row and column and you assume that it corresponds to X and Y, but it's actually the other way around. It's like the row is how far down do you go, and the column is how far over. So it's the opposite of X and Y, where you go over first and then vertical. But this is still missing one thing, because when we have the bricks, they have spacing in the middle between them, like mortar between real bricks, but they also have some on the outside. So we actually need 2 of these, like that. And what that means is they're going to be multiplied. So this is going to be scooting over just enough. Hey, I don't know if you can see because it's only a few pixels, but it has scooted over, and you'll definitely see when we add more. So the Y is going to be almost the same thing, switching out this is the top offset thing, and this is height instead of width, and this is row instead of column. And hey, look at that. It's moved a bit more noticeable because they want more room on top. So let's do this a couple times to see if it's on the right track. We'll do group of 4 so we get to see the different directions. And hey, look at that. They are spaced out. It looks good. I know we haven't done the color yet, but we'll get there in a second. Let's make a function to loop them. We could make a row and then another one for the whole thing, but I'm just going to do one function that does all the ugly row and column together. So, and I'll call it make bricks with an S this time. And so we'll go, this is our, usually we'll say I, but in this case I'm going to go R for row. And then it's going up to num rows. See, all these constants that they've set for us are really making it easy. We don't have to figure out much except these 2 lines. And then R++. So what this means is it starts at 0 and it goes up to 7 or 8, I think. And then we're going to have the column, and I'll call that C. And then it's like num bricks per row, so it's how many. Even though columns are a vertical thing, when we say column, we mean which column are you moving into horizontally. And then C++. Hey, that's a programming language, C++. Now, let's say add make brick of R and C and close our brackets. And then we'll call that function. What if, what happened? A line, what is all this? I must have made a mistake here. Oh, I've already put add. I need to say return. Like that. Okay. Hey, there we go. That's kind of hard to look at. The black and white is so high contrast. Let's do the color business. So I'm going to say that they tell us to use red, orange, green, and blue. But honestly, they're too bright. The green hurts my eyes and the red is very strong. So let's do like a Valentine theme. We'll do some little pastels. I'm going to make a list of colors and then we'll index into it with the number that we need. So if you look on here, they have a bunch of paths to get to the color. So you can use a all caps constant. They have red, green, yellow, and some others. You can use hexadecimal. You can use 3 integers for RGB, which we've done before. But they also have just a string, and we've actually done that before too. These are the CSS colors. Remember when we did the lesson where you had to use like salmon and lemon chiffon and all of these classic, sounds like Crayola colors. I think some of them are actually. We're gonna do that here. Now you can use whatever colors you want, but I'm gonna go pink. I was checking earlier, there's one called Thistle, which is a very nice, mild color. There's a light blue, which we've definitely used before. And then I'm gonna go with a plum. So this is a constant, meaning it's not gonna change, but whichever one we use is gonna be different each time. So I think the first 2 rows are gonna go with the first one, and you could space it out if you like, whatever looks good. How are we gonna do that? Well, how about right here, brick.set color, and then we're gonna go colors with an index. What they want is 2 of each. So like they say 2 red, green, blue, whatever. I'm gonna go 2 pink and thistle. So we're gonna go row divided by 2, rounded down. So we're gonna go math.floor. Is there another way to do that? Yeah, I'm sure there is, but this is gonna work. Let's see. Oh, beautiful, look at that. It's Valentine, or maybe even Easter. And it's a lot nicer on the eyes, I think. It might look too weak compared to the ball. If it's like a solid black ball, maybe we'll lighten it up a bit. But guess what? It doesn't matter. We can do whatever we like. So now let's take our Pong and copy it into here and then make some changes to make it work. This thing with the make bricks, this is one step short of what I would do. What I would do is put these in an array and then return the array. But actually, the way that they tell us to do it in the directions is don't keep track of the bricks. We're going to let the screen handle it, so that instead of looking through all of our bricks and seeing which one collides, we're just going to ask the screen. We're going to say, hey, is there anything at this pixel? Yes or no? Okay. And that's a function called getElementAt. I've never used that before, but they had it in the directions for this, and it seems to be pretty nice, so I'll follow what they ask for. I'm going to go to this, which is what I did in the previous video, and I'm just going to copy paste it into here and see what happens. So at the start, we might need to initialize some of our things, but maybe not, because like I said, we're going to ask the screen to handle it instead of having our coordinates directly. But guess what? They do it the same way. They have an array, and they check the contains point method behind the scenes, I'm pretty sure. So let's say I want to take this guy into the start, probably, or maybe in the initialize if we want to like restart at the beginning of the game. We'll think about it. And then I'm going to take the constants and put them up at the top with the other constants. In general, this is how code is going to be organized. You'll have constants at the top, and then functions or classes, and then at the bottom is like your main or your start or whatever it is in that programming language. And hey, ball radius, we're not using that. Paddle stuff, we're not using those in ours, but maybe we could, or maybe we could just delete them. And then let's see what we got here. I'm gonna hit run and see what happens. Okay, so it is there, and it has the game working. There's no collision. They don't know about each other, and it's way too big. The ball is way too big. If we did collision with this, it would be grazing the corners so often, and it would look weird. So let's go ahead and use that ball radius. Why not? Okay, and then maybe the paddle should be thinner. But we're only going to have one. We're not going to have our two-player version that we did. So let's go ahead and just delete one of these guys. Is there anywhere else where paddle 2 comes up? We're going to use our Control F. Boop. Boop. And then get it to refresh. Okay, I'm going to run again just to see if we caused any errors. Nope. Okay, the next thing we're going to do is move the paddle to the bottom instead of the side. I guess you could do breakout the other way and put the bricks on the side, but either way we'd have to move something. So let's go over, and by the way, this is going to change to be left and right, you know. Let's go over here. Where do we set position? So the ball X doesn't really matter because it's going to start moving soon. The paddle X is going to be the same thing in this new version. So I'm just going to go width over 2. And then over here, this is where we're going to go like height minus something to be bottom, screwed it up. So height minus, I think 10 is the number we use, but maybe we should give it a name just like we did with the brick breathing room. And then we're going to go paddle dot height, which is a reminder that we need to switch those things. We need to say that the width and height are reversed. So should we use their constants? Maybe. We'll get there in a second. Okay, this is great. we have this guy on the bottom, and it's about to get some movement. So let's change this to left and right. On the CodeHS tutorial, they use mouse position instead, so we can take the x coordinate of the cursor and follow that. That would be great. We might try that. But first, let's try what we've got. Yeah, looks good. Okay, it doesn't bounce. You can't see it because of my webcam. But it didn't bounce, so we have to make the collision work. And that's basically it. By the way, this is what I was showing one of my students. We don't actually need that. It was something he was doing in his where he had two balls, like billiard ball style. So over here, let's see what we got. We need to bounce off the sides, but not the top and bottom. So that's the opposite of what we had before. Let's see, is it going to hit the side? Yeah, great. We need to collide with the paddle, but in this case, it's boop. Now, you might notice we're doing this a lot, where it's like ball dot something plus or minus radius. Should we do those once and then reuse, like we should have a ball top, ball bottom, ball left, ball right, and then just use those throughout the code? Probably. We'll see if it's common enough that it matters. Let's see if it bounces now. Yes, but it bounces the wrong way. We're going to switch the y velocity and go up. Great, beautiful. Okay, now we need to bounce off of these guys, and this is the new thing I was talking about with this function called getElementAt. And it is a global thing. It's like the getWidth and getHeight. It's not attached to an object. I mean, I guess it is the canvas, but it's hidden from us, built into the way it works. So let's say I'm going to go down into the update, and every frame we're going to say, hey, is there anything at this pixel, like top of the ball? And if so, then it breaks and we turn around. So let's put it right here maybe. Collide with bricks. Okay, so the way you do it is you say, I'm going to say broken brick. This is like a potential broken brick. It might be nothing. In fact, most of the time it is nothing. So we could call it maybe brick or something. In fact, what happened there? I was holding backspace and it jumped. In fact, we could call it maybe brick to emphasize the fact that we don't know. This getElementAt function is going to be ball.x and then ball.y minus ball.radius. And for me, I'm a little suspicious that if we say what is here and we give it a point that's part of the ball, it'll just say, hey, it's the ball. I don't know which one comes first depending on which ones we added to the screen. I don't want to be fragile like that, so I'm just going to say -1. So this is 1 pixel above the ball, so if we ask what's in this pixel, it won't include the ball, okay? And so this function is going to return null, which is just nothing, which is like a default blank object in JavaScript, or an item, and in this case it's going to be a brick. Hopefully it's not the paddle. I guess the top of the ball could hit the paddle sometimes, and we'll see if we want to handle that. But for now, we're just going to say if maybe brick, which means if it's not null, then remove maybe brick, and y velocity is positive, which is down. Okay, let's try that. Boing. Hey, look at that. It's really nice, right? We didn't have to loop through them and check every frame. If my guy moves kind of slow, and it makes it a little bit harder than it seems because you have to stay in range, and if it starts moving toward one of the sides and you're not Close enough. It's like what happens to a tennis player when the other guy moves you over this way and they shoot it over that way. So this is great, and this actually works wonderfully. The only issue is it can graze the corner of these tiny bricks, and the side is not nearly big enough to be worth colliding against, because if we choose just the point of the ball, it won't touch. It'll just hit some other point at some random angle of the ball. So what I showed in class, for some of you guys, I showed making the bricks a lot fatter, and then it's got a nice surface to hit against. Or you could make it really destructive and just like destroy multiple bricks in one move. That could be fun as well. Whatever you think is worth looking at. Change the color, change the size, change the speed, change the controls. Look at that. I was hopeless because I wasn't ready. Or you could make it reset. And I thought I did make it reset, but maybe that was the Pong version where it's looking for the horizontal. Let's do that real quick and then we'll call it a day. Let's say, y, let's say if y is less than, meaning this way, or y is greater than, and it does our initialize. Remember what we did with the Pong game where it kind of fades in for a second and it gives you time to catch your breath? That's still here. It does it at the beginning and it does it now. It should probably have, oh, what happened there? What's going on? That is probably messed up by our initialize thing. Oh. Our initialize was adding, and then it was adding more. So it was making 2 layers of bricks, and it was actually breaking one, but then you would just reveal the one behind it. That could be cool in some kind of super tough mode where you have to hit the bricks twice to make them break. But I think what we should do is just put this in the start and then turn that into something we think about later. So let's just let it fall off, and then now there shouldn't be, yeah, they're back to breaking, which they were breaking before, but there was another one behind it that made it appear like nothing was happening. So this is great because it was kind of simple. When I used this get element add, I went, wow, that's it? Really? Great. But it always adds complications if you test it, try it, combine it with things. And what did we do today? We added 4 lines here, we changed 2, and then we did this, which was a bit annoying, but we've done lots of rectangles. In fact, this function is pretty much the same as it was when we made the stripes on the flag. We just had to find where each one goes. And this function, where we do the double loop, is very similar to the one way back when we did Carol the Dog racetrack, where it had to go around a bunch of times. It was just 2 loops. So this is combining a bunch of things that we've done before, but making it come together all as one. Have fun.